What if I told you that there's a single story that connects everything? A story that starts with the Big Bang and ends with, well, right now. Today, we're diving into a really powerful idea that ties the entire history of the universe into one single epic narrative. So, let's start with a little puzzle. What could a star, a single living cell, and a massive, sprawling city possibly have in common? I mean, they seem about as different as you can get, right? One's in space, one's microscopic, one's man-made. But what if there's a deep connection hiding in plain sight? And the answer is they're all just different chapters in the exact same book. The same grand, unfolding story of evolution. It's a journey of things getting more and more complex over time, and it didn't start with life on Earth. It started with the very first moments of the universe. Now, this whole idea is at the heart of what some call universal evolution, or big history. And it asks us to stop thinking about evolution in separate little boxes, cosmic over here and biological over there. Instead, we're going to see them as totally interconnected parts of one long, continuous story. This completely flips the script on how we usually think about evolution. The main idea here is that change, and specifically change towards greater complexity, is just a fundamental thing the universe does. It starts with simple particles, which clump together to form atoms and then stars. Those very stars then cook up the heavier elements needed for planets, and eventually for life and for us. Each new complex thing is built from the pieces of what came before. It's one seamless chain of events. But here's the thing. This process isn't just a slow, steady, gradual crawl. Not at all. Sometimes evolution takes these massive, world-changing leaps forward. These are the moments that completely rewrite the rules and unlock totally new ways for things to exist. And there's a great scientific term for these leaps: aeromorphosis. You can basically think of it as evolution leveling up. It's not just a small tweak or a minor improvement. It's a fundamental reorganization that creates a much more complex, much more capable system, whether that's a star, an animal, or a whole society. Think of it like this. Gradual change is all about doing things better, fine-tuning something that already exists. An aeromorphic leap, though, is about doing new things. It's a radical shift that changes the entire game and opens up possibilities that just didn't exist before. Okay, so let's make this real with some examples. A huge aeromorphosis in the early universe was the birth of the first stars. In an instant, cosmically speaking, you go from these boring, diffuse clouds of gas to these massive, stable energy generators that start creating all the heavier elements. That was a quantum leap in how organized the universe was. Then in biology, one of the most incredible leaps ever was the jump from single-celled life to complex, multicellular life. This single innovation allowed for cells to specialize, to form tissues, organs, brains, everything that makes up creatures like us. It wasn't just more cells, it was a whole new way of being alive. And bringing it home to our own story, a massive aeromorphosis for humanity was the invention of agriculture. This wasn't just about finding a better way to get food. It completely rewired human society. It led to villages, cities, governments, everything we now call civilization. A total game changer. So these leaps, they can seem pretty random, right? Almost miraculous. But what's really fascinating is that researchers think they actually follow predictable patterns. You could almost call them the rules of change. And one of the biggest rules is this. These huge, transformative innovations almost never happen everywhere all at once. They usually start small, in some specific, maybe even isolated place. It's only after they prove themselves there that they start to spread and change everything. But, and this is a huge but, there's a catch. Every single one of these evolutionary leaps forward comes with a price tag. It's an idea called the payment for evolutionary progress, and it basically means that with more power and complexity, you always get new problems and new weaknesses. And you can see this throughout our history. The leap to agriculture gave us civilization, but the payment was rigid social hierarchies and the new ability for diseases to become devastating epidemics. Industrialization gave us incredible technology, but the price is pollution and a changing climate. And our amazing global internet, it connects us all. But it also creates a system where a financial crisis or misinformation can spread across the planet in seconds. So if every leap forward brings new dangers, why would any system ever take that risk? Well, the answer a lot of the time is crisis. Periods of major instability, resource shortages, collapse, intense competition, they create immense pressure. That pressure forces a system to either make a radical change and find a new way to work, or just fall apart completely. Okay, so let's bring this right home to our own part of the story's social evolution, because while it follows all the same universal rules, there's something about the human chapter that has put this entire process on hyperdrive. So, what's our secret sauce? It really comes down to three things. First, we have culture, which lets us pass down knowledge through learning, not just slow and steady genetic inheritance. Second, we have symbolic communication, language, writing, which lets that knowledge build up over generations. And finally, we have human agency, this unique ability to consciously look at a problem and then change our environment to solve it. And the effect of all this is, well, it's staggering. Just look at how the time between these huge social leaps gets shorter and shorter and shorter. We went from agriculture to the first states in roughly 7,000 years. Okay, but from the Industrial Revolution to the internet, just a little over 200 years. The pace is accelerating like crazy. And what's driving this is a really powerful positive feedback loop. Each new innovation, like writing or the printing press or the internet, makes it easier and faster to share ideas. That burst of shared knowledge then fuels the next big innovation, which makes sharing even faster still. It's a snowball rolling downhill, getting bigger and faster all the time.
And all of this, it brings us right to this moment, to today, which leads to the final, really big question. If this process is still happening, and it's speeding up, where are we heading? What is our next great leap?
The mind-bending reality is that we're not just waiting for the next auromorphosis, we are living smack in the middle of one right now. For the first time in the history of this planet, humanity has become a single, deeply interconnected planetary scale system. That is a fundamentally new level of complexity. And just like every leap that came before, this one comes with a serious trade-off. Our global system gives us the power to coordinate and innovate on a scale that was unimaginable before. But that same interconnectedness also makes us incredibly fragile. Now, a crisis, whether it's financial, ecological, or a pandemic, can cascade across the entire globe at terrifying speed. We have both unprecedented power and unprecedented risk, all at once. Which leaves us right here with this final thought. We know that crisis often forces a transformation, and we know that for the first time in 13.8 billion years, a species, us, has agency, the ability to see what's coming and maybe do something about it. So, as we face these huge planetary challenges, is the next great leap in how we manage ourselves something we can consciously choose to build? Or is it an inevitable change that some future crisis is going to force upon us? The story of the universe is still being written, and right now, we're the ones holding the pen.